In the previous session, we were looking into the concept of operations on matrices, and we have studied some three operations: addition of two matrices, scalar multiplication to a matrix, and difference of two matrices. And we are left with one more operation, that is product of two operations. Before going to the product of two matrices, we will see some problems which involve these three operations like addition, difference and scalar multiplication. We will see some problems and we will continue with product of matrices as we move on. So we have example. If A is a matrix given by, it is a 2 by 3 matrix. First row is 8 0, second row 4 minus 2, third row 3 6, and B is a matrix which is also 2 by 3 matrix. Then find the matrix X such that 2A plus 3X is equal to 5B. So we are supposed to find the matrix H provided A and B are given. So we are having A as a 2 by 3 matrix and B is also 2 by 3 matrix. Therefore, so we can add the multiple of A, add the multiple of B, or we can subtract the multiple of A with multiplicated with B. We are supposed to find X, therefore we are rewriting the equation 2A plus 3X is equal to 5B. Yes, 3X is equal to, we write for X, 5B minus 2A. Therefore X is equal to 1 by 3, 5B minus 2A. So in order to get X, first you have to find 5B and 2A and perform the operation of difference and then scalar multiplication for that matrix. First we have B as 2 minus 2, 4 2 minus 5 1. Therefore 5B means scalar multiplication to B. This is multiplying each element with 5. This is 5 into 2 is 10, minus 10, 4 2 is 8, 2 2 is 4, 5 2 is minus 10, minus 5 2 is 10, minus 10, 1 2 is 2. This is 5B. Now we have A as A is equal to 8 0, 4 minus 2, 3 6. Now we need 2A. 2A is equal to, multiplying each element with 2, 16, 0, 8, minus 4, 6, 12. So this is about 2A. Now 5B minus 2A is equal to 10 minus 10, 8, 4, minus 10, 2, minus 16, 0, 8, minus 4, 6, 12. So we have to find the difference of these two. So we have to find the difference of the corresponding elements of 5B minus 2A. 10 minus 16, minus 10 minus 0, 8 minus 8, 4 minus of minus 4 means plus 4, minus 10 minus 6, 2 minus 12. This is equal to 10 minus 16 is minus 6, this is minus 10, 0, minus 16, 8, this is minus 10. Now to get X, we have 1 by 3 of 5B minus 2A. So scalar multiplying this 5B minus 2A with 1 by 3 is equal to 1 by 3, minus 6, minus 10, 0, 8, minus 16, minus 10. So multiplying each element with 1 by 3, this is minus 6 by 3, minus 10 by 3, 0 by 3, 8 by 3, minus 16 by 3, minus 10 by 3. So if simplification is possible, we can do, otherwise no need to do anything. So this is minus 2 by 6 by 3 means minus 2, minus 10 by 3, 0 by 3 means 0, this is 8 by 3, minus 16 by 3 is as it is, minus 10 by 3 as it is. This is how we can find X value. So the finding of X involves the operations of scalar multiplication to a matrix, difference of two matrices. So using the operations which we have studied, we can find X. So this is about this example. We will see one more example. So find X and Y. If X plus Y is equal to, which is a 2 by 2 matrix, and X minus Y is also 2 by 2 matrix. Here X plus Y and X minus Y is given, then we have to find X and Y. So we have to find what is X and what is Y. First we will consider X plus Y is equal to 5209, X minus Y is equal to 360 minus 1. So we can observe, in order to find X, you have to just add the two things. So X plus Y plus X minus Y is equal to, just addition, 5209 plus 360 minus 1. So to add these two matrices, just adding the corresponding entries. This is 5 plus 3 is 8, 2 plus 6 is 8, 0 plus 0 is 0, 9 minus 1 is 8. Now, so in the LHS we have 2x because the minus 5 plus 5 gets cancelled. 2x is equal to 8808. Now we need x, therefore x is equal to 1 by 2 times of 8808. So this is scalar multiplication with the matrix by 1 by 2. So multiplying each element with 1 by 2, this is 8 by 2 means 4, 8 by 2 4, 0, 4. So this is about x. To find y, just we can observe subtracting x plus y with x minus y. So that is x plus y minus x minus y. This is equal to 5209 minus 360 minus 1. So in the LHS, x plus y minus x plus y. So plus x minus x get cancelled. So we are left with 2y in the left hand side. In the right hand side, 5 minus 3 is 2. 2 minus 6 is minus 4. 0 minus 0 is 0. 9 minus of minus 1 is 10. Now 2y is equal to 2 minus 4, 0, 10. We need y. Therefore y is equal to, we are taking 2 this side. This is 1 by 2. 1 by 2 times of 2 minus 4, 0, 10. Multiplying 1 by 2 throughout, 0, minus 2, 0, 5. So this is how we can find y. Therefore we have x as 4404 and y as 0 minus 2, 0, 5. This is how we can find x and y provided x plus y and x minus y is given. So this is about the example for finding x and y. So we have one more example which is in terms of real situations. Let's see what example says. Two farmers, Ramakrishna and Gurcharan Singh, cultivates only 3 varieties of rice, namely Basmati, Parmal and Naura. The sale of these varieties of rice by both the farmers in the month of September and October are given by the following matrices A and B. So they are having 2 farmers, Ramakrishna and Gurcharan Singh. So they will sell some different varieties of rice, Basmati, Parmal and Naura. So they are selling the rice in 2 different months. First they are selling rices in September and in October. So they are performing the sales execution in September as well as October. They are given in terms of 2 matrices A and B. So the rows correspond to the people Ramakrishna and Singh and columns corresponding to the rice varieties. Now they asked to find, we have 3 cases, find the combined sales in September and October for each farmers in each variety. So combined sales means we have to add combined sales in September, October. So just by adding A and B, we will find the combined sales in both September and October for both the farmers because the rows are correspond to 2 different farms. Next, find the decrease in sales from September to October. Decrease in sales means September to October. So in order to get decrease in sales, we have to differentiate the matrix A. We have to subtract B from A. So A minus B will give decrease in sales. If farmers receive 2% profit on gross sales, compute the profit for each farmer and for each variety sold in October. So they are focusing on October sales, and if for each farmer get 2% profit, so 2% profit means if suppose we are having B, so 2% of B will give the profit on sales in October. So we will see one by one case. For the first case we have combined sales in September and October. Combined sales in September and October. So as combined sales means we have to just add the 2 matrices because having A plus B will give combined sales. A is 10,000, 20,000, 30,000, 50,000, 30, 10,000 plus B will give 5,000, 10,000, 6,000, 20,000, 10,000, 10,000. So we have to just add the corresponding entry. 10 plus 5 is 15,000, 20 plus 10 is 30,000, 30 plus 6 36,000, 50 plus 20 70,000, 30 plus 10 40,000, 10 plus 10 20,000. So this will give the combined sales in September and October. So this row corresponding to Ramakrishna and this correspond to Singh, and this is for first variety Basmati, this is for Parmal variety, this is for Naura variety. So this is the combined sales in September and October with respect to two farmers and with respect to two varieties of rice. Second one, decrease in sales. Decrease in sales from September to October. September from means first we have to take September. Where it is from, we have to take it first, and next coming the next. So from September means from A to October means A minus B. So A minus B you can observe as A is having 10, 20, 30, 50, 30 and 10,000, and it is 5, 10, 6, 2, 20, 10, 10. So just we will subtract the corresponding entries. 10 minus 5 is 5,000, 20 minus 10 is 10,000, 30 minus 6 is 24,000, 5 minus 20 is 50 minus 20 is 30,000, 30 minus 10 is 20,000, 10 minus 10 is 0. This is correspond to Ramakrishna, this is correspond to Singh, this is for Basmati, this is for Parmal, and this is for Nora. So this is how we will find the decrease in sales. So this much amount of sale is decreased compared to September to October in case of Ramakrishna with respect to the Basmati rice. Next, about third case, 2% profit on gross sales. So profit correspond to October. We have to find 2% of B. So because October is with respect to the matrix B and it is 2% profit, we have to multiply the matrix B with 2%. 2% means 0.02. 2% means 2 by 100. This is 0.02. So multiplying B with 0.02. B is 5,000, 10,000, 6,000, 20,000, 10,000, 10,000. So just multiply with 0.02. So this can give, so it is like 2 by 100. So 2 by 100 means 5,000 into 2 by 100 will be, this is 100. 10,000 into 2 by 100 will give 200. So 6,000 will give 120. So this will give 400. This is 200. This is also 200. So this is about the percentage profit in October sales. So 2% profit he has gained. So the first row corresponding to Ramakrishna, second row correspond to Singh. First is for Basmati, second is for Parmal, and the last one is for Naura. So this is how we can find the percentage increase. So what we can confer from this matrix 2% of B is that Ramakrishna receives 100 rupees profit with respect to Basmati rice, and he receives 200 rupees with respect to Parmal rice brand, and he receives 120 rupees profit with respect to Naura rice brand. Similarly, Singh receives 400 rupees profit with respect to Basmati and 200 rupees profit with respect to Parmal and 200 rupees with respect to Naura rice brand. So this is how we can use the concept of matrix in case of real situations. So this is how matrix operations are helpful. So this is about some examples on three operations which we have studied in the earlier case: additions, difference, and scalar multiplication. If we can observe the difference operator is used, here it is scalar multiplication is carried out. So likewise we can use the operations in variety of cases in order to get the solutions. Next we will move on to the concept of multiplication of matrices. So as we have seen, in order to add two matrices they should be of same order. In order to difference two matrices they should be of same order. But in case of multiplication it is somewhat different. Suppose we are having a matrix A and which is of order m by n, and B is a matrix of order p by q. Then in order to carry out the product A into B, so multiplying A with B, we have to have the condition that n is equal to P. So if suppose n is equal to P means the number of columns of first matrix will be equal to the number of second matrix, then we can carry out the product of those two matrices. Suppose we are having two matrices of same order, means they are of order n, means n rows and n columns, and B is also having n rows and n columns, then we can perform A into B, because number of columns in first matrix is equal to number of rows. In this case also we can perform B into A. Suppose we have A is a m by n matrix and B is a n by p matrix. We can observe number of columns of A is equal to number of rows of B. We can find A into B, because m by n, this is n by p, so the condition for multiplication holds, and then the order of the matrix A into B will be, so number of rows of first matrix and number of columns of second matrix. So this is how we can perform multiplication of two matrices, and what will be the order of the two matrices. We can see, suppose we have A is m by n matrix and B is n by p matrix, then A into B is defined because number of rows columns of first matrix is equal to number of rows of second matrix. This is of order m by p. But if suppose we check what is the multiplicating B with A, suppose B with A means whether B into A is possible or not. I am taking B as first and A as second. So B into A is not possible because number of columns of B is equal to P and number of rows of A is M. Therefore B into A is not defined. So it is not necessary that if suppose A into B is defined, then B into A need not be defined. So if it is defined, it need not be defined. If it is defined, it need not be defined. Therefore there is no need to have both the A into B and B into A simultaneously. Sometimes both will happen, and sometimes only one will happen. Sometimes both will not happen. If suppose we are having A is a matrix of order m by n and B is a matrix of p by q, then such that n is not equal to p, then A into B is also not possible. M is not equal to q, then A into B is not possible, and also B into A is not possible. If they are both are of order n, then both A into B and B into A is also possible. So therefore there is no restriction that if suppose A into B is defined, then it doesn't imply that B into is also defined. So this should be remembered in case of product of two matrices. So in order to carry out the product of two matrices, the number of columns of first matrix would be equal to the number of rows of second matrix. In that case only we can multiply the first matrix with the second matrix. So and about what is the order of the obtained matrix? A is of order m by n and B is of order n by p. Then the product matrix is also having the number of rows, order as having number of the first matrix into number of columns of second matrix. So this is about the order of the product matrix. So how to carry out the product? What we will do is, suppose A is a matrix of order m by n and B is a matrix of order n by p, then A into B is defined. So element is Aij and this is Bjk. So it should match with this, therefore I am writing it as Bjk. Then the resulting will be Cik. I correspond to M and K correspond to P. So this is about A into B, how to find A into B. So we can say an example so that how to take product is clear. Take an example. Suppose the matrix C is equal to 1, minus 1, 2, 0, 3, 4 and the matrix D is equal to 2, 7, minus 1, 1, 5, minus 4. Then check whether C into D is defined. If it is defined, then find what is C into D. First we have to check whether C into D is defined. So C is of order 2 by 3 because it has 2 rows and 3 columns, and D is having 3 rows and 2 columns. We can observe as we are performing C into D, number of columns of first matrix is 3 and number of rows of second column is 3. So therefore C into D is defined. Therefore we can find CD. Now C into D is equal to, just we will write the matrix C. So then it is D. 2, 7, minus 1, 1, 5, minus 4. So how the procedure of product will carry out is, we have to multiply first row with first column and first row with second column and second row with first column and second row with second column. So first multiplying first row with first column, 1 into 2 plus minus 1 into minus 1 plus 2 into 5, and it is about first, and second one is 1 into 7 plus minus 1 into 1 plus 2 into minus 4. And next, so 0 into 2 plus 3 into minus 1 plus 4 into 5, and here 0 into 7 plus 3 into 1 plus 4 into minus 4. So this will give the product of C and D. So 1 into 2 is 2, minus 1 into minus 1 is plus 1, 2 into 5 is 10. And here 1 into 7 is 7, minus 1 into 1 is minus 1, plus 2 into minus 4 is minus 8. And here 0 into 2 is 0, 3 into minus 1 is minus 3, 4 into 5 is 20. 0 into 7 is 0, 3 into 1 is 3, 4 into minus 4 is minus 16. This is equal to 13 minus 2. This is 17. This is minus 30. This is the product of two matrices. As I said, the order of the product matrices will be number of rows into number of columns. This is 2 by 2 matrix. This is how we can perform the product of two matrices. We can see some more examples. If find AB, find the matrix A into B. If A is equal to 6, 9, 2, 3 and B is equal to 2, 6, 0, 7, 9, 8. So before finding A into B, whether it is possible or not, we have to check. A is a matrix of order 2 by 3 because it has 2 by 2. It is number of rows is 2, number of columns is 2. Now for B, number of rows is 2, number of columns is 3. Now the number of columns of first matrix is equal to the number of rows of second matrix. Therefore, A into B is defined. Just we have to multiply. A into B is equal to, order of the A into B is equal to 2 by 3. So it should be 2 by 3 order. So this is 6, 9, 2, 3. Multiplied with 2, 6, 0, 7, 9, 8. As I said, multiplying first row with first column. 60 into 2 is 12, 9 into 7 is 63. And multiplying first row with second column. 6 into 6 is 36, 9 into 9 is 81. So multiplying first row with third column. 6 into 0 is 6, 9 into 8 is 72. Next row, 2 into 2 is 4 and 3 into 7 21. This is multiplying second row with first column and multiplying second row with second column. 2 into 6 12, 3 into 9 is 27. 2 into 0 is 0, 3 into 8 is 24. Is equal to, is 63, 75 and 20, 100, 110, 100, 17 and this is 72, 25 is 39 is 24. This is, we can observe, number of rows is 2, number of columns is 3. So this is about the product of two matrices A and B. So as I said, we can take a remark on the product of two matrices. A into B is defined, does not imply B into A is also defined. So it doesn't mean that if AB is defined, then BA is not BA is also defined. For example, we can take A is a matrix of order m by and B is a matrix of n by q. Then A into B is defined because the number of columns of A is equal to number of rows of B. Therefore, A into B is defined. But we can check first B into A. So the number of columns of first matrix is equal to q, but the number of rows of second matrix is m. Therefore, B into A is not defined. Therefore, there is no need that if AB is defined, then B is also defined. So AB and BA will define only when both cases will happen. Suppose if A is a matrix of order m by n, B is a matrix of n by m, then AB is defined. Similarly, we take BA, here also BA is defined. BA is defined. So in order to exist both AB and BA, it should be noted that the number of columns of first matrix is equal to number of rows of second matrix and number of rows of first matrix is equal to number of columns of second matrix. In that case, both AB and BA will exist. And it should also be remembered that if both AB and BA exist, then it doesn't imply that BA is equal to AB. So BA is equal to AB, it may exist or it may not. What I am saying is, if AB exists and if both AB and BA exist, then whether AB is equal to BA, sometimes it is true, but sometimes it is not true. Therefore, It is not always true that AB is equal to BA. So it is like the commutative law. So what we say is the matrix multiplication is not always commutative. Matrix multiplication is not always commutative. Sometimes both will be equal, sometimes not equal. Therefore, we are saying matrix multiplication is non-commutative. Because we have to see all the cases now. For example, we can confirm with an example. So we are taking an example. If suppose A is equal to 1 minus 2 3 minus 4 2 5, B is equal to 2 3 4 5 2 1. Then find AB and AB, BA, and show that AB is not equal to BA. So in order to find AB and BA, we have to check with the number of rows and columns. A is a matrix of order 2 by 3, B is a matrix of order 3 by 2. Then AB is defined because the number of rows of first column is equal to number of columns of first matrix is equal to number of rows of second matrix. Therefore, AB is defined. The order is 2 by 2. And we can check BA. B is having 3 by 2 order and A is having 2 by 3. So and columns of B is equal to columns of A, means number of columns is equal to number of rows of A. Then BA is also defined and order of BA is 3 by 3. So just by observing the orders we can tell AB is not equal to BA because two matrices of different order can never be equal. So just by observing the orders we can just say both are not commutative. So we don't do that like that, but just we will follow the procedure. First we will find AB. Now AB is equal to 1 minus 2 3 minus 4 2 5 and B is 2 3 4 5 2 1. So multiplying first row with first column, 1 into 2 is 2 and minus 2 into 4 is minus 8, 3 into 2 is 6, and multiplying the first row with second column, 1 into 2 is 3, minus 2 into 5, this is minus 10, 3 into 1 is 3. Second, multiplying second row with first column, minus 4 into 2, minus 8, 2 into 4, 8, 5 into 2, 10. So second, minus 4 into 3, minus 12, 2 into 5, 10, 5 into 1 is 5, is equal to 0. So this is 6 minus 10, minus 4, this is 10, and 15 minus 12, this is 3. So this is about A into B. Now we will see what is B into A. B into A. So first we are taking B, 2 3 4 5 2 1. This AB is a 4 2 by 2, and second 1 minus 2 3 minus 4 2 5. Multiplying first row with first column, 2 into 1 is 2, 3 into minus 4 is minus 12, and first row with second column, 2 into 2 minus 2 is 4, minus 4, 3 into 2 is 6, 2 into 3 is 6, 3 5 is 15. Second row, 4 into 5, 4 into 1 is 4, 5 into minus 4 20, minus 20, 4 into minus 2 minus 8, 5 into 2 is 10, 4 into 3 is 12, 5 into 5 is 25. Multiplying third row with first column, 2 plus 2 minus 4, 2 into 3 is minus 4, plus 2, 2 into 3 is 6, plus 5 is equal to minus 10, 2, 21, minus 16, 2, 37, minus 2, 11. So this is about B into A, as it is of different orders that of A, AB. Therefore, A into B is not equal to B into A. Therefore, the matrix multiplication is not commutative. It is not always commutative, but sometimes they are equal. For some matrices it will happen, AB will be equal to BA, but it is not always true. AB is equal to BA is not always true, therefore matrix multiplication is non-commutative. Now we will see an example. It is going to give some new remark. So if A is equal to 0 minus 1 0 2, B is equal to 3 5 0 0, then find A into B. Now A into B is possible because both are of having same order, both are of having of matrices of order 2. If AB is defined, both B is also defined. Now AB is equal to 0, 1, 0, 2 and 3, 5, 0, 0. This is equal to 0, 3, 0 into 3 is 0, minus 1 into 0 is 0, and 0 into 5 is 0, minus 1 into 0 is 0, 0 into 3 is 0, 2 into 0 is 0, 0 into 5 is 0, 0 into 2 into 0 is 0. Is equal to 0, 0, 0, 0. So A into B is equal to 0 matrix of order 2 by 2. So we can observe that A into B is a 0 matrix, even both A and B, even then both A and B are not 0 matrices, non-zero matrices, but we are getting A into B as a 0 matrix. So there is no rule that the product of two matrices is 0 imply A and at least one of matrix is 0. Therefore A into B is equal to 0 does not imply A is equal to 0 matrix or B is equal to 0 matrix. Even if both are non-zero, then the product can be 0. So this is a remark. So which says that if the product of two matrices can be 0 even when both are non-zero matrices. It should be remembered. We can write it as a remark. If the product of two matrices is 0, it is not necessary that one of the matrices is a 0 matrix. What it says is, if A into B is 0, doesn't imply that either A is 0 or B is 0. Now we can see properties of multiplication of matrices. Properties of multiplication of matrices. First one is associative law. What it says, if we are having three matrices such that the product will exist, then A into B into C is equal to A into B into C. The associative law holds for three matrices such that the product is possible. For any three matrices such that the product is possible, then A into B into C is equal to A into B into C. So this is the associative law for multiplication. Next one is distributive law. So multiplying A with the product sum of two matrices. So A into B plus C is equal to A into B plus A into C, provided the product, all the products involved should exist. And one more case, we can have A plus B into C. So this is left multiplication, this is right multiplication. A into C plus B into C. So this is about distributive law. Next one is existence of identity. That means, suppose A is a matrix such that there exists a matrix P such that A into B is equal to Y, then B is called identity matrix. As we have seen, I is a matrix such that the product doesn't alter the original matrix entries, therefore A into I is equal to A will happen. This I is called identity matrix, and this is the identity matrix with respect to multiplication of matrices. Identity matrix is given by of order n is given by 1 0 0 0 0 1 0 0 0 0 0 0 1. So this is diagonal matrix, the all diagonal is equal to 1. So these are some properties of multiplication of matrices. We will see some examples on these laws, whether they may be associative law, distributive laws, and some more examples which we can see in the next class. Till then, keep watching.